The last part of the polar front depression that we need to consider is the occluded front. Up to now on our system, we only have a warm and a cold front. However, you may have noticed that the speed of the cold front is greater than that of the warm front. Therefore, the cold front will catch the warm front up. This is called the occluding process. It usually begins as the low-pressure system as a whole stops deepening. We shall look at this now. Seen from the top, as more and more of the cold front catches up with the warm front, the longer the occlusion becomes. In fact, given enough time, the cold front and warm fronts will disappear to be replaced by one occluded front. But what's going on? Let's take a sideways look. Here we see the situation before the occluding process starts. We have the warm front, the cold front, and the warm sector in between. As the cold front catches up with the warm sector gets smaller until eventually all it is a narrow wedge with its tip at the surface. As the cold front continues to push on, the wedge of warm air is actually lifted away from the ground completely. It is at this point that the occluded front forms. Of course, the wedge of warm air is lifted away from the ground first at the tip of the warm sector where it is narrowest. That's why the occlusion builds from that point and spreads down the rest of the system. Where the cold, warm and occluded fronts meet, we call the triple point. The fronts are often very active at this point, with thick cloud and heavy precipitation due to the increased lifting of air that takes place. There are actually two types of occluded front, a warm and a cold occlusion. The type of occlusion depends on the relative characteristics, especially the temperatures of the two air masses ahead of the warm front and behind the cold front. If the air behind the cold front is warmer than the air ahead of the warm front, this happens. This is called a warm occlusion and will have the appearance on the ground of a warm front. On a weather chart, note how the occlusion is drawn as part of an extension of the warm front. Warm occlusions are more common in winter because the cold European landmass will provide polar continental air ahead of the approaching polar front. On the other hand, if the air behind the cold front is colder than that ahead of the warm front, then this happens, and we have a cold occlusion. See where the main areas of cloud and precipitation development are. Note that on a weather map, this type of occlusion is drawn as an extension of the cold front. On the ground, it will seem very much as if a cold front has passed. These cold occlusions are more common in summer months across Europe. An approaching frontal system will encounter warm air ahead of the warm front. Occlusions in general move at about the same speed as cold fronts. The weather associated with occluded fronts is very variable, sometimes highly active with thunderstorms, heavy precipitation and sharp changes in wind direction. On other occasions, especially when the low centre is far removed from the occluded front and the system is old, the occlusion can be ill-defined. On a weather chart looking like this, we call the occlusion a backbent occlusion. This is often of the cold variety and sometimes is thundery in nature, but in winter months can be a significant boundary behind which lies the true, cold, Arctic-type air. For this reason, the precipitation on this type of front in winter can readily turn to snow, with very cold air undercutting the warm wedge of air that hangs higher up in the atmosphere. The whole process of the formation of a polar front depression takes around 4 days on average, with the decay often lasting for up to 10 days before it's absorbed by another pressure system. Speed and movement of polar front depressions varies greatly through their lifespan. At first they move quickly with the flow, becoming slow-moving and almost stationary by the time they decay. At their height, their track and speed can be calculated like this. Looking at this weather chart, the low centre will move in the direction of the isobars in the warm sector, with a speed approximately equal to the isobar spacing near the triple point. Let's now take a look at a summary of the passage of warm and cold fronts. Ahead of a warm front, the wind will steadily increase in speed and back slightly. It is often southerly in the northern hemisphere. The temperature will remain fairly steady and is low. The dew point is usually steady and fairly low. The pressure will fall steadily. The cloud will increase and base lower. Precipitation will set in, becoming persistent and moderate in intensity. The visibility will reduce to poor. At the warm front, the wind will veer sharply. The temperature will usually rise. The dew point will suddenly rise. The pressure will still decrease slightly. The cloud will be low and remain fairly constant. Precipitation will be continuous and moderate, perhaps heavy. The visibility will be poor with widespread hill fog developing. In the warm sector, the wind will be steady, usually from the southwest in the northern hemisphere. The temperature will remain fairly steady. The dew point will remain steady. The pressure will decrease slightly. The cloud will remain low and fairly constant. Precipitation will become light and patchy in nature. The visibility will remain poor with extensive fog over high ground. At the cold front, the wind will veer sharply with gusts and possibly squalls. The temperature will usually fall. The dew point will suddenly fall. The pressure will start rising. The cloud will be low, but start changing in character. Precipitation will be moderate, with heavy bursts and perhaps thunderstorms. The visibility will be poor in the precipitation, but quickly show signs of improving. Behind the cold front, the wind will steadily veer slightly more to the northwest in the northern hemisphere. The temperature will be steady, or quite often will rise depending on the time of day. The dew point will be steady and low. The pressure will continue rising, but at a slower rate. The layer cloud will clear and convection will start with tall cumulus and cumulonimbus towers forming. Precipitation. Showers will develop, becoming perhaps moderate or heavy in intensity. The visibility will become very good, but will fall during the showers. That completes the lesson on air masses and fronts. It is a very important part of aviation meteorology, and it is vital to understand the various points that have been brought out through this lesson.